Just a minute. That means I will put a border line so that want to confirm the space up to where I can write. Up to here. Okay. Continue. We are almost reaching the end of the structural design by RCC, the RCC part. But see, practically this is very important here. And remember, some calculations are there. But you don't have to do later. Why? Everything software will take care. But only purpose is to learn. I told earlier. I forgot to admit. I reduce its size. Charging on. Charging is on. I'll check once again because most dangerous. Charging on. Okay. Just tell me. Voice clear? No, voice clear? See, I put one line here so that tell me up to here visible means sufficient for me. Up to here. There I written a sketch for some reason. I will put later. I will not go beyond this line later. Voice clear? Okay. Now, see, last time I already told you some important points you have to write. This is for, see, this is all for longitudinal bending. Longitudinal bending. There is transverse bending also is there. Okay. That is, I will show you by using example here. See, this one. You should write yourself. Okay, this is something gone here, no problem. See, one column is here. You should write all these things. How you write, your choice. See, one column here, one column here. This length is, I don't know. See, you can calculate. Some 9 point something is there. What is the width of footing? Tell me. What is the width of footing? You cannot see it. Tell me, what is the width of the footing? 1 point. How much? Width of footing. How much? 1.95 meter. Okay. Width of footing is 1.95 meter. Okay. Don't see that. Now see, we are considering lengthwise bending. And remember, load is kilonewton per meter square, upward load. But we consider the entire load for this width. So what you have done, whatever is the load in kilonewton per meter square into 1.95 you have done. So these are all in, see, all these are in kilonewton per meter, not meter square. First of all, these are all already over. Okay, now, this is only lengthwise bending. What will happen? See, this will sag due to pressure. This will sag. Center will hog. I will use my head only now. What to do? See, I will use my head only. See, center will hog. This bending, see, I will put the bending here. See this way. See this way. Sag, sag, and hog. See, this is the bending. Length. This hole is not there. This is lengthwise bending. Now, so this is all. See, this is the SFD. This is a BMD. These are all considering what? Considering footing as a wide beam, that is of breadth equal to 1.95 meter. This is all for what? So that is whatever load comes for 1.95 meter, everything is accounted. So this is the loading diagram. I have not entered the value because you know it already. Sfdbmd. Okay. Now further, what you have to do is, see, these are all I told you. Point of quantum flexure, A, B, C, D, this is called E, this is called A, this is called B, this is called E, this is called O1, this is called O2, everything is over. Now, even I told you, sagging, see, elastic curve also I told, forgot right here, okay, you can write yourself only, forgot right, somewhere here, see, sag, hog, space is not there, hog, and sag. So, tension at the top, tension at the bottom, tension at the bottom. Bottom steel, see, for this region, I should not spoil it. For this region, you design for how much? 446.2 kilonewton meter, safer side. This region, you design for 660.5. The central region, where steel is at the top, design for 374.6 kilonewton meter. This example, center is hogging. After this example is over, I will take one more example. Why? Very popular. So many times the columns are quite nearby. In that case, entire this lengthwise bending will be only sagging. Means what? BMD will come this way. So full sagging. Practically equally important. So after taking that one, I will conclude then by explaining the principle of this is only slab type, the most popular for footing at present. But I will also explain you briefly which one? Combined footing of beam and slab type. Remember, full design I will not make. Why? Because I will tell the principles here. Those who go to structural engineering field, when they master all these things, with my principle, they can easily design. So, and then with that one, I will stop the YouTube class. YouTube will stop when I finish combined footing with beam and slab type. Only explanation, no numerical. But still, your ETABS class will run one more class. Anybody can tell for what? After combined footing is over, ETABS class will run for one more class before the software part. Anybody can tell one more class for what? ETABS class will run for one more class. One more class for what purpose? Where ETABS and RCC batch only will participate. Only ETABS batch and RCC batch will participate. Anybody can tell for what? Anybody can tell for what purpose? Think a little. Isolated footing over, combined footing over. Next what? Why this much delay? Next what? You know it already. No idea. Next what? Pile all will not come here. Next will be raft footing, where more than 2 columns, from 4 columns may be there. That I will not take in the YouTube. Reason number 1. There are 2 reasons. Reason number 1. It is highly complicated for analysis. Highly complicated for analysis. Reason number 2. We will make lot of approximations, but on safer side. So when approximations are done, different people will have different version, slight adjustment. I do not want tomorrow somebody to comment, no, he told that way, he could have done this way. He will not see me. He will not see my class. Only those who are in the group, they will not tell that way, I know it. Those who join my RCC class and ETABS class, they will not comment that way, I know it. Others, no, public it will not be there. It will be only for Once again, class will continue in Zoom only then. That is RAP routing. But later, in the software part, RAP will be done easily by software. Okay, now, one very important note you have to write. See now, this is the variation for lengthwise bending parameter, Sfdbmd. This is for width of 1.95 meter. But see, if I take the plan, see here, you should write this note. I will not explain once again. Plan. One column here. One more column here. Okay. Now, load is here. Load is here. Couple is here. Couple is here. Now, there is no strip taken here. This entire is for bending this way for the full width of 1.95 meter. Now, tell me. First of all, this type of bending will come. Tell me, will it come for a strip in the outside portion or a strip running below the columns? Tell me, this type of bending, see, sagging here, hogging here, the loads are acting here. So, this type of bending will come. Will it come for entire width or for some width which runs the strip which runs under the column? Tell me. Entire width. What is this? How it can bend here? How it can, see, how you can expect that bending here? Where is support here? This I told earlier. You have not followed earlier class. You have not followed earlier class. Earlier class I told you clearly. Entire width means, why should I bother? How it is for entire width? See, think a little. This type of bending. See. Okay, I will take a stick member. See, the column loads are here. See, this type of bending, see, laterally, when the column pressure is there will be some lateral bending also will be there. And the outside portion, to bend this way, supports are required. Where is support? So, this type of bending will take place where? For entire width or for ETABS you told 1 meter width. Where I told you? Where I told for ETAB 1 meter strip. I told you this type of bending covering the full width, the complete loading for the full plan area. That is upward load for full width. That's why the pressure we multiplied by 1.95. It will come only under the column. See, this type of bending you can expect under the column. See, here. Then only you can see what? Point load here, etc. Suppose as the strip goes away and away, tell what will happen. As the strip goes away and away, the lengthwise bending, this lengthwise bending will increase or decrease. As the strip goes away and away, if I take a strip this way, away and away, either side, the lengthwise bending will increase or decrease. It will reduce. So, I will tell you one thing now. See, don't see the width here. Suppose you take a strip here. Software will give you later bending moment diagram. See, it will give you like this. Now, I will project down. Critical. Now, if I take the strip somewhere here, some strip, any width will do. Even because of the influence here, some bending will come. But software will give you, see, this way. Whereas, if I take a strip at the extreme end, you know how software will give you? This way it will give. Means what? The lengthwise bending will keep on reducing as you go outer side, this way, outer side. Now, therefore, for safety, you should design for the strip under the column or elsewhere. This all you have to write. For safety, we want safety. For safety, always critical. You should design for a strip under the column or elsewhere. First, you should design for a strip under the column or elsewhere. Where you should design? You should design for a strip under the column or elsewhere. Shall I provide steel, etc. for bending for this strip or this strip or this strip? You are not answering. Under the column. Now, this is the Sfdbmd for what? This is the Sfdbmd for no strip taken here. For when you consider entire width bending. But actually, if you come, this is based on average value. So, when you take a strip under the column, critical, tell me, that is if you take a 1 meter strip here. See, later, in the ETABS class, I will show you strip here, strip here, strip here. You can see this way, decreasing, decreasing. Therefore, if you take a strip of 1 meter width, this way 1 meter strip, see, this is 1 meter strip here, then the SF and BM, see, now what I will do is, all this SF and BM, what I will do? All this SF and BM is for loading considered for 1.95 meter strip. Loading considered for 1.95 meter width. Now, we want for 1 meter width. Tell what to do. So, for full, when you consider the upward load for 1.95 meter, this is SFD, this is BMD. Suppose you consider the load only for 1 meter, your SF and BM value will be more or lesser. First, this is the Sfdbmd for the load which is due to full width. Whatever intensity is there, pressure intensity, we multiplied by 1.95. Now, but if you multiply with only 1, that is, if you take a strip of 1 meter width here, the shear force and bending moment, will it be more than this one or less than that one? First, tell the answer. It will be lesser. Don't worry, it will be lesser. So what you will do is make a note. Now we will consider a strip of width 1 meter. See, now make a note. For this strip, design strip, this is called design strip. If I take a strip here, effect is lesser. Now I want result for 1 meter. What do you do? Therefore, SF values, SF and BM values, we can get from SFD and BMD drawn, see, SF and BM values for 1 meter strip, 1 meter strip under the column, under the columns, running under the columns. I will not repeat once again. See, danger one. First of all, for this also, some will comment. If they comment, I will tell them, come in front of me and comment. That's all. If they got courage, let them come in front of me and comment. Let me see what happens. Okay, sir. SFDM values for 1 meter strip under the columns, we can get from that BMD drawn considering full width of 1.95 meter. That is full load for 1.95 meter by, that is what? That is these diagrams. See, that is these diagrams right here. These I written here. By what you have to do? Multiply by 1.95 or divide by 1.95. Simple common sense. Somebody with a little knowledge will tell. That is for those are the BM, SFBM for when you consider loading for full width. But we want SFBM only for 1 meter strip. So by multiplying by 1.95 or dividing. First, by multiplying or dividing. By dividing by, see, by dividing by, I will not tell again and again, full red color, dividing by 1.95 meter for this example. Don't by heart 1.95 meter. See, that is the full width, L2. That is L2 value. 1.95. Okay. But, you write this way. But, you see, red color. There is a problem. What, tell me? But there is a problem. What is the problem? There is a problem. Tell me, what problem? If you divide by 1.95 meter, somebody will tell, then why don't you take in the beginning 1 meter strip? I can take 1 meter strip. Then load I can't take 1100. Load I have to take 1100 by 1.75. That load I should take 1400 by 1.95. This couple I should take whatever is that couple by 1.95. This couple I should divide by 1.95. Then when you divide 1.95, what you are getting, same value will come here also. But that is not correct. Okay, now, but there is a problem. Anybody can tell what is that problem? Think a little. You make a note here. When you divide by 1.95 meter, you are assuming everywhere bending is same. But it is the problem. That is, that Sfdbmd are drawn considering full width will participate in the bending. But actually, full width will not participate. It will participate, no doubt, under the column, little severe effect. Elsewhere, lesser effect. I have told you bending on RMS now. As you go away from the column, the lengthwise bending will keep on decreasing. So, therefore, if you divide by 1.95 meter, see, you are somewhat getting average basis, correct? You are getting some average basis, yes or no? Divide by 1.95 means you are getting average basis, assuming that this bending and this bending both are same. You should write. That is, you are assuming that what? Whether you take 1 meter here, whether you take 1 meter here or 1 meter here, bending is same, which is not true. When the moment you take a strip under the column, average value is wrong. It will be slightly, what? Tell me. It will be slightly more than average, not too light. It will be it will be somewhat little more than average or less than average. Little more than average or less than average. Little more than average or less than average. Answer. This also I told you last time. It is little more than that average basis or lesser. This is a critical. It is more than average or less than average. Little more. How much more? We don't know. How much more? We don't know. So I propose to increase by, problem is what? Problem is, see, there is average, but there is average. Problem is, there is a problem right here, that the bending, if you consider directly a strip under the column, then software also will give the value not divided by 1.95. It will give little more. Therefore, what we will do is, see, we will divide by 1.95 first. We will divide by 1.95. Tell the reason. Why? Make a reason. This is very important. We will divide by 1.95. Reason. Because those values are corresponding to total downward load and also full width, whatever pressure comes. Now we want pressure only for 1 meter strip. So to get it, divide. But we will magnify it. Say by approximately, I told you 25%. Okay, I think okay. But this is only for learning procedure. Actually, if you go to software, it will take care of everything. It will not do this way. Finite element method, when you draw a strip here, it will give critical values. So therefore, divide by 1.95 to remove that. For whatever you got for 1.95 width, you are reducing to 1 meter. Clear? Because these are the result for a width of 1.95 meter. When you divide by 1.95 meter, you will get the result for meter strip. So, here, therefore, after dividing by 1.95. Don't buy at 1.95. It is like whatever is the width there. We get result for 1 meter strip. 1 meter now. Is it visible? What I wrote on the board, visible or not? Okay, visible. We get result for 1 meter strip. But actually, because your width strip is under the column, it will be slightly more. Therefore, we will multiply by, that is, multiply by how much? Tell me. You divide by 1.95 to get per meter strip. Then multiply by how much? I want around 25% more. Multiply by. When I want increase by 25%, if you cannot tell, multiply by how much? Class cannot be continued. Class cannot be continued. Multiply by 1.25. 1.25 over. See, just to understand correctly, I will tell you what is the simple language. Simple effect it is. See, morning, say for example, 8 a.m. to 12 a.m. somebody is working. Somebody is working. Now, 4 hours he is working. 4 hours. He completes work of around 20 units. 20 units work he completed. Tell me. 4 hours he completes 20 units of work. Therefore, per hour, how many units? Tell me. Per hour, how many units? He completes, you write this example, no problem. He completed some 20 units of work. 20 what I don't know. 4 hours, 8 a.m. to 12 a.m. Somebody completes 20 units of work. So per hour, how much? Per hour, how much he worked? That is per meter strip. Per hour. This is also difficult. Per hour. 5 units per hour. 5 units per hour. But one thing, if you consider 1 hour, 8 to 9, he will complete 5 units. If you consider 9 to 10, he will complete 5 units. If you consider 10 to 11, he will complete 5 units. 11 to 12, he will complete 5 units. No, it is not that way. Most probably, earlier time, fresh, at 8 o'clock, he will complete little more than 5 hours or less than 5 hours. As the time goes by, he will get tired. Remember, it is a physical activity. So, 8 o'clock, first 1 hour, he will complete 5 or little more. Tell me. If after 4 hours, if you inspect, if 20 minutes are completed, but actually guaranteed, if it is a physical activity, maybe first hour, he will complete more or lesser. First hour. No. These all cannot be explained. No, sorry. It has gone beyond the limit. I told all the principles. What? You told even the axial load and couple should be. No. Pressure calculation, don't do all these things. I told only for bending Sfdbmd. Pressure calculation full. What is this one? Pressure these all principle came after pressure calculation. Till the pressure calculation, we never discussed anything. It is only what? When you draw a Sfdbmd, instead of drawing for 1.95 strip, 1.95 width, if you draw for 1 meter strip, then divide by 1.95. Not for pressure calculation. Pressure calculation same, P by A, M by Z. Now, this way I cannot go back. No, not for pressure calculation. Okay, now, tell me, you are answered. 8 to 9 a.m., 8 a.m. to 9 a.m., tell me. He will complete 5 or more than 5 or less than 5. Because why? Morning fresh. Answer. It maybe he has done 5 instead of 5, he might have done 6. No, initially work done is more, but totally correct. See, this total 1.95 correct, but actually first 8 to 9, maybe he completed 5, not 5, 6. 9 to 10, not 5, little more, 5.5. But 10 to 11, maybe 4.5, that way. Next, 11 to 12, little more than 4. Why? As he got tired, his rate of work is reduced. But total 20 hours, so 20 units. Duration, 4 hours. So you can tell 5 units per hour. But actually, somewhere in some particular hour, it will be little more. Clear or not? In some particular duration, it more. That is, the bending will be more for a strip under the column. Clear or not? Furthermore, I can't make clear. Clear now? Why I am multiplying by 25% more? Why I am multiplying by? Somebody may not agree. He will tell, how you know 25%? Okay. Somebody may ask me, okay, if he got enough courage, how you know 25%? I will ask him, tell me how much? I don't know. Then keep quiet. Then keep quiet. If you know, tell me. I can't decide. Then why you commented, first of all? If you do not know something, what I tell you, believe. That's all. So many people believe me, you become one among them. Or don't come to my class. If such a negative comments you are doing. Anyway, these all you don't have to do. This variation, the real bending under the column strip, ETAB will take care. When you take a strip under the column, ETAB will take care of that variation. So you don't have to worry. This is only for understanding. See, I told you, in the software, your diagram will come this way first, under the column. As you go further, it will become lesser. See, as you go further and further away, it will come further lesser. See, suppose take a small strip here, it will become very, very lesser. See, I will show you in the ETAB. Yes or no? Okay. Those who are in the ETAB batch, I will show it in the ETAB class. Agreed? Those who are in the ETAB class batch, I will show it in the ETAB class. Those who are in the RCC batch, you believe me. You believe me now. That's all. Those who are in the ETAB batch, I will show it there. I will show different strips and you will tell, yes. You told that day. Okay. Now, therefore, remember, whatever results you got here, remember now, final conclusion. So therefore, I will make a final conclusion here. I will not tell again and again. Final conclusion. Right here. Whatever result we got there, which is for 1.95 meter, SF or BM, whatever is there, which was for 1.95 meter width, divide by 1.95 meter. Then you get the result per meter strip. And since you are to safer side, critical bending here, we will enhance by how much? 25%, 1.25. This value will give design value, design SF and BM for 1 meter strip under the column. Under the column. See, sensitive matter. Such things, people will sometimes I will tell you, if someone wants to tell this way, what he will tell? He will not tell this much. He will just tell, see, these are all for width of 1.95, okay? Therefore, divide by 1.95, you get answer. Then, see, the column strip will have a little more bending, so let us increase by 25%. Okay, now start, over, see. If I do that way, foundation part, I need not take up to 12th, 13th class today. All these YouTube classes would have been curtailed in 4 or 5 classes, or ETABS&SAFE. RC, what all I took so far, more than, now it is not 100 hours, it may be more than 120 hours, almost equal to the full course duration. I told earlier, full course 150 hours. Now, around 120 hours now, another 10 hours more. So, but don't worry, ETABS&SAFE, I will do justice. I never consider time. Oh, I committed that much. Let me finish fast and start new batch. I never do that way. So, there this much time came because by important understanding. Now, is this point clear? I am not telling once again. Simply that if you refer that one, divide by 1.95 but multiply by 1.25. Some people may comment on that one. My question is, you tell me how much. I don't know. Then keep quiet. If you know, teach me. I will ask plenty of questions. See, I know finite element method. Therefore, if they tell something like FEM principle, I can trap them within no time. I will ask them, what is shape function? He will tell N1. Don't tell me N1, N2. Shape function meaning what? I don't know. Then keep quiet. You don't know the meaning of shape function. You are talking about finite element method. Okay. Don't worry. Anybody knows shape function? Okay, leave it now. Why should I go out of subject? Now, is this point clear means I will rub and start. If this point is clear means I will rub and start. Okay, start. Now see, make a note, just one note, and I will start now. Little work is there for you also today. This all are. Now, simply right here, red color, go through again, not your Gujarat Titans, GT means, not that team. Go through all the explanation given from 7:30 p.m. to 8:15 p.m. today and understand everything, and finally conclusion is that we will take 1 meter strip under the column. 1 meter strip running lengthwise. I won't write why. You should write running lengthwise under the column. That is what? That is this way. I won't write again now. See, if you take a strip under very small, further severe will come. This way, 1 meter strip. Now, we are back in slab. Why? So, B equal, tell me, when you design for this 1 meter strip, tell me what is B equal to. Tell me fast. I won't repeat it till now. What is B equal to? Structural B. What is structural B? Somebody may ask, what is structural B? Leave the class. What is structural B? 1 meter or 1000 millimeter. Over. Now, one more thing you have to write. And remember, those values are, when you consider here, what you do is, you divide by 1.95. So, from 1.95 strip, it will come to meter strip. But because of the severe effect under columns, increase by 25%. Some people may tell 50%. Okay, increase by whatever you want. Or, first of all, we are not doing by for the strip there, and it will give correct answer. Okay, hour. Now, dividing I already told you. So remember, any result, when you use from there, divide by 1.95, multiply by 1.25. But don't use it for distances, only for answer. Over. Now, start. See, start now. I told you strip now. Tell me. Now, first, decide depth of slab. Depth of slab. It is not called slab thickness because, tell why. Now, see, if the slab is of 100 mm, 200 mm, you can call slab thickness. If the slab depth is coming 800, 900, do you call thickness? Tell me. Suppose there is a slab. See, width 1.95, length some 9 point something, depth around 0.9 meter. It comes that way. Will you call it thickness? Tell me. Will you call it as thickness? Okay, thickness only. Will you call it thickness then? See, will you call it thickness? What do you call? Don't call thickness. Call it as what? Thickness you call when plan area is much bigger and thickness is smaller. Then you call depth only. Even RCC also, thickness is the depth only. Okay, now, that is D. capital D. Start. Equate maximum mu to mu limit. Now, maximum mu, tell the answer. Maximum mu for design purpose equal to, see the chart there, answer. Maximum mu, answer fast from there. Remember, mu means factored. Factored. Tell the answer first. Maximum mu. See the bending moment diagram. Tell me the maximum mu. Fast. Maximum mu. From the bending moment diagram, it started raining also. No. Tell fast. No. Tell me maximum value of the bending moment value from diagram. Tell me what is the maximum BM ordinate in the diagram. No. What is the, don't multiply, I will multiply. You just tell me for fixing the depth, the critical BM there. Answer. Is it 800 point? What is that number? Tell me. 800.5. Okay. Tell me, this I written small because it is already over last time. I wrote for my reference. Actually, I should rub it. If I rub it, if I ask, you will not tell the answer. Don't write this one. It is the closing of last class. 800.5. See, 800.5. But be careful. 800.5 correct. But what I will do is, I will first divide by 1.95. Tell why. For reason. 800.5 is a display. I will first divide by 1.95. Reason fast. Reason fast. Reason. I will divide by 1.95. Reason. Now onwards I will not repeat this one. Now onwards I will not repeat this one. For 1 meter width. Then I will multiply by 1.25. Tell why. This is my personal number. Somebody may not agree. Tell why. Multiply by 1.25 means enhance it by 25%. Why? Enhance it or consider for safety little more. That is for accounting for the critical bending. Now, these are all what? Working load. Then into 1.5. Why? Reason. What is this 1.5? What is that 1.5? What is that 1.5? What is that 1.5? That is factoring. See, these are all for working load. Okay, 1.5. Tell me answer in kilonewton meter. Kilonewton for 1 meter strip. 1 meter strip under the column. Under the column. I told you repeatedly. Answer. 800.5 by 1.95 into 1.25. That will go with the correction. Into 1.5 for factoring. Don't give wrong value. 769.7. 769.7. Okay, now equate mu or now do one thing. Write formula for mu limit. You write. Why should I write? You write. Somebody may tell, sir, we don't know. Then why you came to RCC class? Or those who are, actually I told earlier, if you are studying combined putting you on study, you don't know formula for mu limit, you are not fit for structural design. Okay, start. Now, equate, wait, red color. Equate mu to mu limit. You get 769.7 into 10 to the power 6 equal to 0.36 into 0.46 into 1 minus, I think we are using M25 and FE500. Tell yes or no. I think we are using, I want to know, M25, FE500. Yes or no. I want confirmation. Yes, okay. Into 0.4, 1 minus 0.42 into 0.46 into 1000 into d square into 25. Tell me what is the d required. It will come in millimeter. Fast answer. Nobody can ask me what is the equation, how you got all those numbers. If you ask how you got all those numbers, you are not fit for structural design or footing. You will learn first RCC part. And nobody can tell what is this 0.36 from where we got. Just magic. Okay, magic. I got by magic. Fast answer. If you don't give, you are forcing me to calculate. Don't give wrong value. 480 mm. Sakbidi. Children beda. 480 mm. Now, assume diameter of bar. Assume, or let us initially consider. 1 minute. Tell me. Shall we see? This is 480 is the D. Correct? Now, we are going to increase it by around 75%. Considering what? Tell me. This 480 will not give. Later, once the depth comes, will increase by around 75%. Some people take double. Accounting for what? Accounting for. Some people take double. Accounting for footing slab it is. Accounting for what? For what? Shear. Therefore, this is almost like a beam. See, width of 1.95 meter, depth of around 1 meter, and length of around 9 meter. Does it look like a slab? Tell me. Does it look like a slab or beam? Does it look like a slab or beam? Tell me. Actually, okay, your structural design is slab. Correct. But even does it looks like a beam, but we are doing like a slab. Okay, therefore, don't take 10 torr, 12 torr. If you take 10 torr, 12 torr, bar will come so close that bar bend will run away. Take higher diameter. Isolated footing, I told, take around 16 torr in the beginning, later reduce. Here, no. Heavy steel will come. For safer side, take higher diameter. Remember, practically some places I have seen 32 torr. Not here. For ground plus 10 floors all, I have seen footing slab, reinforcement lengthwise 32 torr. But usually, I think under normal case, I will take 25 torr. 1 minute now. I will take 25 torr. Later, for some reason, instead of 25 torr, you give it lesser diameter. Okay or not? Suppose you take 25 torr now. But later you find 25 torr is not required, 20 torr will do or 16 torr will do. Then okay or redesign required? Okay. This I told so many times for RCC and ETABS. You assume a diameter, later if you reduce the diameter, good. Why? D will increase. Okay. At clear cover of for footing slab 50 millimeter. Therefore, tell me what is the capital D required. It is 480 minus 50 minus 25 by 2. Tell the answer. 480 minus 50 minus 25 by 2. Fast. Thereby 480 minus 50 minus 25 by 2. It is 542.5. ಇಲ್ಲ ಸುಮ್ಮನೆ ತಮಾಷೆಗೆ ಹೇಳಿದಷ್ಟೇ. ಇದು ಗೊತ್ತಿರಬೇಕಿಷ್ಟು. Just for fun, we are getting capital D from small d. You have to add 542.5 is the depth required. Now, this is the depth required based on what? Tell me. Based on bending or shear. This is the depth required based on bending or shear. Fast. This is based on bending. Based on bending. But We know that for footing slab, you should write, for footing slab, shear is very, very critical. Two types of shear is there. One of them is called punching shear, other is what? One-way shear or wide beam shear, causing diagonal tension. These all, now I will not waste time. Why? Isolated footing, one problem, I took 3 classes. People who finish in half an hour. I have seen recently a YouTube video, complete design of isolated footing. You know time duration, 20 minutes. He did everything. But anyway, that is his capacity. I am little weak in subject, so I take more time. Therefore, let us increase the depth, accounting for high shear effect. You should write. I am not writing because those who are serious should listen to me and write. Accounting for high shear effect by approximately say 75%. That is, try D approximately. Tell the answer. 542.5 around. I think 75 is sufficient. But sometimes you can write a note. If you are doing manual design, you can take almost double. No, in the class 75. How much? Double better. In the class 75, we will face the risk. Tell the answer. Around 75% more. Fast. To increase this step, you should not forget. Suppose you forget this step, later you will have unsafe in shear. 949.375. 949.375. Therefore, I will write, try, all this gone now. All this gone. I will cancel now. Now little work for you. You have to show your talent. Therefore, try capital D equal to, how much, tell me? How much you told? 900 and, how much you got? 949 point something. How much, tell me? Increase slightly, round off. 950 millimeter. Okay, I will try 950 millimeter or even 900 also we go okay. That is not 75, say 70%. Okay, 950. Therefore, actual D provided. Actual provided with this 25 torr, with the 25 torr bars. Later you may change it, equal to 950 minus 50 minus 25 by 2. Answer. Actual D provided in millimeter. Actual D provided in millimeter. Answer. 887.5 millimeter. 887.5 millimeter is the actual D. Okay, now same way we have done isolated footing. Okay, there bending moment came in one line. Here, because of the complication, it became more. Okay, now remember, depth is fixed. Now check for punching shear. Punching shear. Tell the answer. Critical section for punching shear. Punching shear will be as per IS code, will be at what distance? Oh, it started raining heavily. Tell fast. Light now, not much sound. If it comes severe rain, I cannot continue because I cannot hear my own voice. Right now, no problem. Right now, no problem. Some disturbance is there. Okay. D by 2 at D by 2 from face of column. Face of column. That is at D how much? 87.5 divided by 2 equal to, answer, 887.5 divided by 2 equal to, fast, 887.5 divided by 2 equal to 443.75 millimeter. 443.75 millimeter. But remember, when you go for the diagram showing critical section, all dimensions are in meter. That is what? 0.44375 meter. Okay. Or you can do one thing. You can round up to 0.4. Take correct value. 0.44375 meter from face of column. Face of column. This much clear? Fast. Now you have some work. I will take rest. Why? Hard earned rest. Earlier, very thoroughly I explained. Therefore, I will expect, somebody may comment, YouTube class, 15 minutes, he is not taking class. I will tell him, 15 minutes you are supposed to work there. Not tell, I am not taking class. See, angry note. I earned it. Clear? Okay. Now, see, I may forget it now. 0.44375. Okay, 1 minute now. I want the space also. D equal to 950, small d equal to 887.5 with 25 torque, and critical is 0.44375 over. Now, important, see, all gone. I should not tell anything now, first of all, but still I will tell. Write the plan. First of all, you should tell only one point needs clarification now. You need only 1 point for clarification. Otherwise, nothing required. Only 1 point you need for clarification. I will tell you what is that one. See, write the plan. Full page I will write here, because you have to enjoy. Write the plan. Enjoy now. Okay. Write the plan. Remember now. Now, no strip, nothing. Make a note. The 1 meter strip all nothing. Why? Because punching is all round. See, earlier, when you check for punching, you don't take strips all. You take the column, place on the footing. One column is here. One more column is here. Tell me. Okay. Tell me. For this column, I will call column number 1. This I will call column number 2. Tell me, column number 1, what is P? Column number 1. Column number 1. What is the axial load P? Tell the answer. Column number 1, axial load. 1100 kilonewton. And column number 2, axial load, how much? Column number 2, axial load, 1400 kilonewton. Remember, when you design by software, you don't have to check this thing. ETAB will give a number to you. Punching here, it will do. It will show you everything. Now, tell me, what is the side of this column? Point. I want side of this column. Widthwise. Fast. I forgot now. This side of the column, shorter side. 0.2 meter. Don't tell wrong value. 0.2 meter. What is the, I think I should put a little bigger. See, little bigger I will write. So otherwise problem. Okay. Out of scale. Okay. Out of scale. Okay. See, this is column number 1. This is column number 2. This is 0.2 meter. All here, everything is in meter. In meter. Okay. 0.2. What is the longer side? What is the longer side? 0.6 meter. This is 0.2. This is 0.6. Column number 2. Tell what is the shorter side? Column number 2. What is the shorter side? Shorter side. 0.3 meter. Thank you. 0.3 meter. A meter beda. Longer side. Longer side. 0.75. Thank you. 0.75. Now, for this column, critical section will come here. For this column, critical section will come here. Scale illa, no scale maintained. Now see. Tell me. This column 1100, this column 1400. Tell me. Do you have to check under both columns or only one column sufficient? First answer. Do you have to check under both the columns or only one column? Do you have to check under both the columns or only one column? First answer. These are all called logical questions. Do you have to check the? No, wrong. You have to check under both the column, because where column load is lesser, see, where column load is lesser, the resisting area also, when you go surrounding here, resisting area also lesser. When column load is more, this will come what? Resisting also more. So no, you cannot tell that way. You have to check under both, because it is not only column load, upward pressure counts, resisting area counts. Here, resisting area is more. See here resisting is lesser. Lesser load, lesser income, lesser cost, higher income, higher cost. You cannot tell who is critical. Somebody earns lesser, he spends lesser. Somebody earns more, he spends more. Who is critical? You can't tell. Who knows? The one who earns more may be critical. He is lavish spender. So you have to check under both. Clear or not? Make a note. You have to check under both. But software will give number for both. In the end, I will tell you what software number will come. Clear? Okay. Start. Now, note. Time to write all this one. See, this is d by 2. This also d by 2. This also d by 2. No space right here. D by 2. One place I will write d by 2 equal to 0.44. I write here now. D by 2 equal to 0.44375. Therefore, tell me what is this side. First, what is this side? 0.6 plus 0.44375 into 2. First, don't give any wrong values. See, it should be more. Okay. Scale ಸರಿಯಾಗಿ ಬರ್ದಿಲ್ಲ ಅಂತ. ಅಯ್ಯೋ, don't bother about scale all. Tell the answer. 0.6 plus 0.44375 into 2. Don't give wrong value. 1.4875. Meet all meter. Tell me this distance. 0.2 plus 0.44375 into 2. That's it. $1.0875. Why? Sorry, anything wrong? 1.0875. Thank you. 1.0875 meter. Tell me here. Here also 0.75 plus 0.44375 into 2. This distance. 0.75 plus 0.44375 into 2. Why this much delay? 1.6375. 1.6375 meter. This way, width here. 0.3 plus 0.44375 into 2. This distance. See, raw footing, you have to check 4 times. Nothing to worry. ETAB will do it. Last I will tell you how this check will be done by ETAB. 1.1875. No plate right here. 1. Kanta idya? What? Okay. 1.1875. Okay, now this column load is 1100. This column load is 1400. Remember. Clear now? Next, now remember, in general, punching shear force, that is in general for any column, for check under any column, punching shear force VP equal to column load minus what? Tell me fast. You should tell now. First of all, I need not tell. It is a downward column load minus. Fast. Very, very thoroughly I explained earlier. Nobody can tell. Nothing is told. Everything is micro parts I explained. Column load minus. These all grinded like anything. Fully grinded earlier. See there. Full grinded. Column load minus. See, you are wasting time. Column load minus. Minus upward pressure, upward net pressure at center of the column multiplied by what? Plan area of critical section. Correct? Critical section. First of all, writing this now itself is an offense. Someone will tell you why you wrote it. First of all, somebody who gives value to education, he will tell me, sir, why you wrote it? For understanding. Did you not tell it grinded earlier? In isoid footing, I saw your class. You told each and every point there. Then, if they don't study properly and come here, let them pay penalty. Let them not do structural design. Let them not learn anything. Something which told repeatedly with the example, so many things around, it will give you little lesser. It will not come 1100. So then why you wrote? I will tell what to do. My teaching instinct. At least remind for them. Now, tell me. Now, we need what? We need net upward pressure under each column. Yes or no? Under each column, we require net upward pressure. Tell yes or no first. We need net upward pressure under each column. At center, under pressure at center of each column. Yes. Tell how to get it now. Remember now, you cannot do by M by Z. What you have to do is go back. You tell me the pressure diagram. See, tell me the net pressure diagram. Net pressure value. Here first. This is A. No, this I told at that time. This is 1, this is 2, this is 3, this is 4. Not A, B, C, D. And remember, your column is here. One more column is here. Tell the answer here. Tell me, what is the pressure here? Or, tell the answer. Or 1 minute now. I took a strip here. Then tell me, what is the pressure here? What is the pressure here? See, you know net pressure here. 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 Fast. This net pressure. Fast. Don't give wrong values. 133 point. No, if you give that way, confusion. Give in correct order. Okay. Later, if you tell 133.48 Sakbidi, illi. 134.63 illi. 138.63 134 point ಅಯ್ಯೋ ಇಲ್ಲ ನೀವು ಕಾರ್ನರೇ ಕೊಡಿ, ಬೇಡ ಅರ್ಥಕ್ಕೋಸ್ಕರ ಕಾರ್ನರೇ ಕೊಡಿ. ಸ್ವಲ್ಪ ಎಕ್ಸ್ಪ್ಲೈನ್ ಜಾಸ್ತಿ ಆಯ್ತು, ಪರವಾಗಿಲ್ಲ. ಒನ್ಸ್ ಅಗೈನ್ ರಿವಿಷನ್ ಫಾರ್ ಯು. ಬೈ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಒನ್ಸ್ ಅಗೈನ್ ಯು ಆರ್ ನಾಟ್ ಲೂಸಿಂಗ್. Or you know, then why you give 4 values there? See, then if you are giving at center, then why you gave 4 values? See, tell the answer. 133.48, 134.94, 145.23, 143.77. ಕರೆಕ್ಟಾ? ತಪ್ಪು ಕೊಡ್ಬೇಡಿ. ಆಮೇಲೆ 133.48, 134.94, 145.23, 130. Okay, now do one thing. We want pressure here, we want pressure here. Here you require pressure. So before that one, tell me what is the pressure here? Fast. 133 all are in kN per meter square. 133.48 plus 143.77 divided by 2. Answer 138.63. Second decimal ಸಾಕ್ಬಿಡಿ. 138.63 kilonewton per meter square. Tell what is the pressure here. Don't give wrong values. Pressure here. Somebody who is watching in YouTube, if values are wrong and if he comments, I will tell, you should come live and tell me. Don't comment on values. 140.09 ನೋಡಿ, ನಾನು ಬರೆದಿರೋ ವ್ಯಾಲ್ಯೂ ಇದೆ, ನೀವು ಜಾಸ್ತಿ ಹೇಳ್ತೀರಿ, ಆಕ್ಯುರೇಸಿ ಬೇಡ. 140.09 kN per meter square. So here 138, here 140. Tell me what is the full length here. This length, fast. This full length. ನೀವು ತಪ್ಪು ಕೊಟ್ಟರೆ ಏನು ಮಾಡೋಕ್ಕಾಗಲ್ಲ. 140.09 ಆಯಿತು. ಈ ಫುಲ್ ಲೆಂತ್ 9.2 ಮೀಟರ್. ಇದು 9.2 ಮೀಟರ್. Tell what is the what is this length and what is this length. ಇದು ಈ ಎಡ್ಜಿಂದ ಈ ಕಾಲಮ್ ಸೆಂಟರ್, this length ಅಲ್ಲೇ ಇದೆ. ಎಷ್ಟು ಹೇಳಿ? there only you can see 1.6 meter and here this is 2.2 meter. 3 ಮೇಲೋಗು 2 meter. Now here pressure is 138.63, here pressure is 140. Therefore from 138.63 along this line interpolate linearly. See, for a length of 9.2 meter, this is 138.63, this is 140. Therefore tell me what is the net pressure here and also tell me what is the net pressure here by interpolation. Answer. Here 138.63, there 140.09. Then length is 9.2. Length is 9.2. And then we want to go by 1.6 meter. Here you have to come that side by 2.2 meter. Answer. By interpolation. Ayo, calculate only, not on. I almost completed. Is it 139.02 kilonewton per meter square at that value? $139.55 kilonewton per meter square. Tell me, correct or not? Is it correct? Is it correct or not? 138.88. ಅಬ್ಬಾ, ಈ ಥರ ಮಾಡಿ ನಾನು ಏನು ಮಾಡೋಕ್ಕಾಗತ್ತೆ? ಪುನಃ ಮಾಡಬೇಕಾ? 140.09 minus 138.63 divided by 9.2 into 1.6. That much add to 138.63. Okay, correct. You are right. ನೋಡಿ, ನಾನು ತಪ್ಪು ಮಾಡ್ತೀನಿ. Calculation mistake I may do, because it is not a joke to stand like this and shout non-stop. I had morning also class. It is not a joke. Those who know the difficulties, they will understand how much difficulty is there to take such classes. Is this also correct? ಇನ್ನೊಂದು ಕರೆಕ್ಟಾ? ಇನ್ನೊಂದು ಆ ಕಡೆದು. One more. At 2.2 from there, answer. 2.2 from there, answer. 2.2 from there, answer. 138.98. ಓಕೆ, ಏನೋ ತಪ್ಪಾಗಿದೆ, ಚೆಕ್ ಮಾಡ್ತೀರಿ. 140.09 minus 138.63 divided by 9.2 into 2.2. That much you subtract from 140.09. I think when I did rate of change, I took a wrong number here. Okay, 139.74 ಬರ್ತಾ ಇದೆ ನನಗೆ 139.74 ಬರ್ತಾ ಇದೆ ನೋಡಿ, ಅಲ್ಲೂ ಚೌಕಾಸಿ. I am getting 139.74. How you got 138? I am getting 139.74 ನೋಡಿ. When I do under the other column, I am getting correct ಆಗಿದೆ. 139.74 ಬಂತು. 139.74 ನೀವು ಕನ್ಫರ್ಮ್ ಮಾಡಬೇಕು. 139.74. If you tell yes, I will continue. ನೋಡಿ, ತುಂಬ ಟೈಮ್ ವೇಟ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ. ಯು ಆರ್ ವೇಟಿಂಗ್ ಲಾಟ್ ಆಫ್ ಟೈಮ್. 98 88. ಅಬ್ಬಾ, ಪ್ರಿಂಟ್ ಮಿಸ್ಟೇಕ್. 1 minute. $138.88 only. How 98? It is 88 only. Other one 139.74. Okay. Yes. Now remember, I will make a note here. Net pressure PN. Net pressure at center of this column. At under net pressure. Okay. At center of this column. This column is 138.88 kilonewton per meter square. Remember, somebody will tell, sir, this much work you are not doing manually, you are doing by software. This is only thing is basic knowledge. Don't do all this practically. Let it be done by software. You should understand the principle. If you do not know what is happening, then how you become structure engineer? Net pressure at center of this column. This column equal to 139.74 kilonewton per meter square. Tell me, fully clear or not? Fast, tell me, fully clear or not? This I am not removing. It will be there for tomorrow's class also. If it is full clear, I will tell you one interesting point. Clear? Okay. Now, this is how you got this pressure. These pressures you got by corner pressure. From corner pressure come to center pressure, then widthwise average, then lengthwise interpolate. Using corner pressure, get to center pressure. Then once you get central pressure here, then lengthwise interpolate. Widthwise average, lengthwise interpolate. That's how you got. Clear? Tell fast. Clear or not? That's how you got. Tell me, clear or not? There's a reason for asking question. There is a reason for asking this question. Clear? Okay. You are not told. Clear. Okay. Now, I am quite reasonably good in basic bending theory. I will not do like this. If somebody asks me this way, I will not do like this. I will directly go to basic. Do you want to know or not? Tell the answer. If you do not want, I will leave it. I will go to the next step. Those who are serious, do you want to know? You should not tell class is becoming lengthy. Do you want to know? Yes, then I will not do any of this calculation. But hope, see, if answer is not tallying, then you will be blamed because you are the one who gave corner pressure. See what I will do. See, I will take the plan. Nodi, ಏನಾಗುತ್ತೆ ಅಂತ. Or light plan. ಅದು ದೊಡ್ಡದು ಬೇಡ. Light plan, full column. Okay. This is 1.95 meter. And this length is 9 point, ಎಷ್ಟದು? 9 point, ಅಯ್ಯೋ, how much ಅದು? 9.2, ಅಷ್ಟು ಮರ್ತೋಯ್ತು. ಅಬ್ಬಬ್ಬಾ, this forgetting is too much. Is it 9.2? 9.2 meter. Okay. Now, for this complete section, this is axis 1, this is axis 1, this is 2. See, there is a, considering both the column, there is a single point load P equal to how much? 2500 kilonewton, correct? And there is a moment lengthwise, most probably like this, I think, correct? Tell me, is the lengthwise moment this way? Tell me answer. Is the lengthwise moment this way or this way? Tell me. In the front view, lengthwise moment is clockwise or anti-clockwise? I forgot. You should refer. Clockwise, front view. How much? I think it is anti-clockwise, I remember. Nodi, if you tell wrong value, problem. What? Clockwise or anti-clockwise? See the sketch earlier. You have got the sketch there. For pressure calculation, this diagram is there. Tell fast. Clockwise or anti-clockwise? For before finding pressure, this diagram is there. Before finding net pressure. No, you are not told. Clockwise, anti-clockwise, you are not told. Clockwise, okay. There is a clockwise pressure of M1 beda ange. Etadu 20 kilonewton meter. And widthwise moment this way. Is it clockwise or anti-clockwise? Widthwise moment this way. Is it clockwise or anti-clockwise? Tell me, widthwise moment this way. Is it clockwise or anti-clockwise? Clockwise 30. Nani yaka doubt ide. Clockwise of 30. But actually, I want pressure here. I want, sorry, ingirli. Ayyo ba, ingirli. Saku. I want pressure here. I want pressure here. This is column number 1. This is column number 2. This distance is how much? 1.6 meter. This distance is 2.2 meter. And this, so this is 9.2. If it is 9.2, half of is how much? Half of is 4 point, 4 point how much? What is half of 9.2? What is half of 9.2? First, 4.6 meter. This is also 4.6. Therefore, tell this distance and this distance. From the axis 2 to, tell the distances here. This distance. For point 1 and point 2, from the 2 to axis, tell distances. 4.6, subtract 1.6. Bega. If you understand, understand. Otherwise, don't listen. Otherwise, don't listen. You already got the answer. This is called extra concept because I am quite reasonably good in strength of materials. 2.73. Abba. From 4.6, If I subtract 1.6, how you got 2.73 meter? ಅದು ಯಾವ 2.73? 2.4 meter. ಎಲ್ಲಿಂದ ಬರ್ತಿದೆಯಲ್ಲ? It is 2.4 meter. Tell me what is this distance? From 4.6 subtract 2.2. From 4.6 subtract 2.2. 4.6 minus 2.2. ತುಂಬ ಟೈಮ್ ತಗೋತೀರ ನೀವು. ಅಯ್ಯೋ 4.6 minus 1.6 2.4. ಇದು ಎಲ್ಲಿ ಬಂತು ನಿಮಗೆ? 3 meter. ಓಕೆ 3. Tell what is this one? This is 2.4 meter. Now, those who understand only understand. Somebody who is watching general public, he may tell, I cannot make out anything. Then you don't consider this one. This is only for those who got capacity to understand basic bending theory. Otherwise, don't go. You already got the answer. What else you want? Now see. Now, net pressure at 1, net pressure at 2. I write here now. Due to P is plus P by A plus P by A. Answer. P by A is 2500 divided by area is full area 1.95 into 9.2. Tell this pressure at A. P by A. That is the net pressure at 1 meter. Net pressure at 1, net pressure at 2. This is due to P. Answer. Due to only axial force 139.35. See, afterwards slight approximate error will come. 139.35 kilonewton per meter square. Same here also 139.35 kilonewton per meter square. Over. Now 1 over. Next I will write here. Where should I write? Some space required. I don't want to remove that one. See, due to 20 kilonewton meter couple, this couple, your pressure at 1 and pressure at 2 I want. Pressure at 1 equal to 20 divided by, bending one is 20 divided by 1.95 into 9.2 cube divided by 12. Why? You cannot use Z concept. Tell why? You cannot use Z concept. You have to write M by I into Y. Clear or not? Your formula is what? M by I into Y. You cannot use Z concept because it is not boundary. It is not extreme fiber. Z can be used only for extreme fiber. Intermediate value by what? By basic formula. M by I into Y. Here Y equal to 3 meter. Answer. But remember, since the couple is this way, this is minus. Answer. Why? If the couple is this way, this side is tension. Answer. Actually, these are all called asking for trouble. Suppose anybody in the teaching line, you tell all these things in the class, if answer is not tallying, you will lose your face. Here, if answer is not tallying, I will lose my face. But I am not bothered because I will not lose my face because such error is impossible. Answer. Answer fast. M by I into Y you are right. Fast answer. ಇಟ್ಟೊತ್ತು ಬೇಕಾ? M by I into Y. ನೋಡಿ, you are taking lot of time. You are taking beyond the limit time. Your time taken is beyond the limit. Just to write M by I into Y, if this much time you take, how to conclude the class? 0.474. 0.474. And net pressure, this is positive, negative. Why negative? Moment this way. Net pressure under the column 2 due to this 20 kN meter is 20 divided by 1.95 into 9.2 cube by 12 into y is 2.4. Tell this answer also. This is positive. Why? This side is compression. Answer. This side is compression. Answer. I will advise you not to go for this one. Some student will tell Kannadadalli, sir, beda sir, beda. Hindi, sir, nahi chahiye. वो भी ठीक है. जो पहले बता दिया वो ठीक है. ये सब क्या हो रहा है सर? पता नहीं चल रहा है. Leave it. I told because I have confidence. 0.379 plus 0.379. Okay, kN per meter square. Now, over. Due to this 30 kN meter, these 2 points lies in neutral axis. Yes or no? See, for this 20 kN meter, neutral axis here. For 30 kN meter, neutral axis lies here. Therefore, due to 30 kN meter, no stress. 30 has no effect. This 30, its variation is like this. Because for 30, this is neutral axis. These 2 points lie in neutral axis. Therefore, no effect. Clear or not? First. If not clear me, tell me first. I will close. It has no effect. See, one answer you are not giving. It has no effect. See, one just to give an yes answer, you are wasting lot of time. I don't know why. Yes. Therefore, finally, net pressure here equal to, tell the answer. Finally, net pressure under column 1 equal to plus 139.35 minus, minus, here, minus 0.474. Tell the answer. Plus 139.35 minus 0.474. Answer. 130. Oh, ella rabbaitili. Abba. P equal to 1100. Okay. Answer. 138.88. 138.88 and net pressure at center of column 2 equal to plus 139.35 minus plus how much? 0.379. Second decimal answer. Plus 0.379. 139.73. I will write 74. I will give 1 paisa tips. I will give 1 paisa tips to it. Take 1 paisa tips. Okay. How much? 139.74 because I know the answer. Tell me, are these two values exactly same as what you got here and what you got here? Tell the answer. Are those two values, by basic bending theory, you cannot use Z concept, exactly tally with the values we got using pressure diagram? First answer. Yes, same. In my class, if any result from strength of material, engineering mechanics or structural analysis there, it should be same. So far, I never got different answer by different approaches. You know, people know, if it happens, what I do, I tell them in my classroom. I won't tell publicly. If something goes wrong in my class in engineering mechanics, strength of materials and structural analysis, what I will do, I told you in the classroom. I will always stick to it. Okay, leave it. Don't comment it. Don't comment there. Somebody will get shocked. Somebody will get shocked. They may give police complaint. He will give police complaint then. The one person is danger person is there. Okay. Now, I will remove this one. Remember now, all those all those who are finding difficulty, do not see this one. Now remember, I am going to stop now. Not stop. Still another 20 minutes time is there. Nodi. 20 minutes time. I will write the value here and silently go that side. I will watch the comments. Before then I will finally stop at 9:30. Till that time, or till everybody goes off. When there is nobody watching, I stop the class. But now it is completely for you. Don't ask me anything now. Start. Start. Check under column 1. Somebody will tell, what is going on here? Column 1. Answer. We. If wrong, you can send in the group. If answer is not telling, you can send in the group. 875.33 kilonewton. VP, VUP. 1313 ayyo 1313 kilonewton. Then tau VP 0.287 Newton per mm square. Now to get tau CP, tau C equal to 1.25. Unit I am not writing. Okay. And then here beta C equal to 0.333. Therefore, Ks equal to 0.833. 0.833. Therefore, tau Cp equal to 1.041 Newton per mm square. Therefore, your tau Vp is less than tau Cp. Therefore, safe under left column. Left column punching is safe. Come to right column. Right column. Vp equal to 970.95 kilonewton. VUP equal to 1456.43 kilonewton. Then tau Vp equal to 0.290 Newton per mm square. Then to get tau Cp, you require tau C equal to same 1.25. But your beta C equal to 0.4. Therefore, Ks equal to 0.9. Therefore, tau Cp equal to 1.125 Newton per mm square. Here also, tau Vp less than tau Cp, safe. Therefore, our footing is safe in punching shear. Very comfortably safe. If you want, you can reduce the depth. Don't do it. One more shear is there later. Safe in shear. Safe in punching shear. Right. Anybody if a comment not explained properly, I will tell in future, never open my class in YouTube. I grinded like anything to dust in the isolated footing. Now see, if anybody cannot do it, not fit for education from my side. Why? That much I explained. I separated the two. Therefore, you just do it now in a rough sheet and comment that both answer came. Whatever you want, 9:20, still another, I am not seeing how many are there now. Till another 10 minutes time, I will wait before closing the class. Before closing the class, I will wait for another 10 minutes. Hope at least somebody will tell, got both. Okay. Tomorrow, I will start the reinforcement part, that is, continue the question. So, because I made everything clear, once you reach here, if you cannot do, I will tell openly. It is not first time. I did it so systematically earlier. Go back, refer, not refer. By this time, you should have studied it. Okay, thank you. We will meet tomorrow. If anybody leaves the class at his own risk, if you are really interested, you get the answer and tell me. Second column getting different value. Why? Which is not tallying? Second column, tell me which is not tallying. Second column, which is not tallying. Tell the answer. Second column, which is not tallying. No, which is not tallying, second column. Which value here is not tallying? You can tell me which value is not tallying. I will check it first. Vp. Let me check it. Okay, not a big issue. Vp equal to, oh, it is coming 1128. Is it coming 1128.27? Tell the answer. Is it coming 1128.27? Yes, okay. I will change it. 1128.27. No problem. I told you, I can make what? Sometimes calculation mistake, not an offense. Thank you. So who gives the answer? Thank you. Thanks a lot for correcting. 1692.41. Now, is it 0.3375? Now correct. 0.3375. Now correct. Tell me. Now correct. Okay. Calculation is not a problem. See, I told you, I may make calculation mistake, spelling mistake, rarely grammar mistake, print mistake. I told technical mistake I will not make. Okay. Now, one person got, congratulations. Others should get the answer. Till 8-minute time is there, I will not be here. I will take rest. I have not taken break today. I will earn that 8 minutes break. Then silently I will come and stop the class. By that time, get the answer. Anybody in public, if they find difficulty, Go back, start from class number 1 of the RCC part. Study everything I uploaded. Not come today and tell, I don't know anything. Then you don't come to my class. Little harsh. It is better to be harsh than tell, please study. I won't tell, please kindly go through my earlier classes. If you want to learn, go through my earlier classes. Sorry for harsh word. I got right to talk that way. I think I got right to talk that way of talking harsh. Because only for lazy people. Okay, thank you. But class will run for another 7 minutes. Till that time in the comment box, I will wait who are giving answer. Just you are right, got both. Your tell got both. Okay, I will close.